Hello everybody. This video is for Algebra A and Algebra B. We're going to go ahead and take a look at the first lesson for week 3 of AMI. This is your assignment titled Solving Systems of Equations by Elimination. So we're going to work through question number 1 and question number 6. We're actually going to work through question number 6 first. When we are looking at systems of equations, if we want to use the elimination method, something that has to happen is all of the equations have to be written in standard form. So before we get into the problems, we are going to take a look at what a standard form linear equation is. So here we have standard form written with all variables and no numbers. We have ax plus by is equal to c. A, b, and c are all constants. I often refer to those as regular numbers or your positive and negative numbers the majority of the time. That way you guys have a good visual of what I'm talking about when I say that word. And then x and y are just your typical variables from a linear equation. And a and b, something specific about standard form is a and b must be integers. So they're going to be a positive or negative number. We're typically not going to be working with rational numbers or fractions when we're looking at standard form. So to start us off, we're going to go ahead and take a look at question number 6 from your assignment. Question number 6 is actually the easier of the two I'm going to work through with you because there are systems of linear equations that are already naturally set up to work well with elimination, and then there's some that take a little more effort to get them ready. So we're going to look at both those scenarios. We're going to start by looking at question number 6. So in question number 6, we have negative 7x minus 2y equals negative 13. And then we also have x minus 2y equals 11. Those are our two equations in our system. So in order to know if this system is ready to use the elimination method on, the first thing I would check for is if they're written both in standard form, which they are. And then we will also then look to see if the x variables or the y variables, if they have a coefficient that's the same in both equations or the opposite, like a one positive and one negative in the equations. So if we look at the two equations in number 6, I have negative 2y in both. So that is why I know this system is set up well for elimination. So what I'm going to do now is I am going to show you how to determine what operation we are going to use to solve the system. Now, the point of the elimination method is to eliminate or get rid of one of the variables out of both equations in order to solve for the one we still have. So for example, we're going to try to get rid of both of the y's or both of the x's. Now, in this problem, we are going to try to get rid of y because y is the variable that has matching coefficients. So we are going to have to think through this. If I have negative 2 and a negative 2, I need an operation that allows me to combine these numbers and make them equal 0. So if I have negative 2 and a negative 2, if I just add them together, that would be negative 4. So that would not be correct. But if I subtract negative 2 from negative 2, we will get the result we want. Negative 2 minus negative 2 is actually -2 plus 2 due to our rules of integers. So -2 plus 2 would be 0 because those are additive inverses. We add those two numbers together and we get 0. Now, from here, we're going to take this idea of I need to need to subtract what we were doing originally, and we're going to do that to all of the matching terms in our original equation. So we'll take -7x and subtract the matching term below it. So -7x minus x will give us -8x. -2y minus -2y will be 0, like we determined over here, which means we won't have a y term in our answer because it canceled out and it no longer has a value. Now we're going to do -13 minus 11, which is going to give us -24. From here, I can solve for x using inverse operations. So go ahead and pause the video and think for a moment about what operation you would do first here. Okay, hopefully you determined that it would be dividing by -8 on both sides because -8 and x were being multiplied originally. When I divide -24 by -8, I get that x is equal to 3. Remember that when you're solving a system of equations, you need two values for your answer, an x and a y. So now that we know the value of x, we will take the number 3 and substitute it back in to one of our original equations. Typically when I'm doing this, I'm going to pick the easier equation to work with, or one that looks like it has simpler numbers. So I'm going to choose to plug 3 or substitute 3 back into the bottom equation. So that's going to look like the following. I'll have 3 minus 2y equals 11. And then we'll need to solve that using inverse operations. So go ahead and pause the video and see if you can figure out what operation we will do first to solve for y. Okay, hopefully you guys determined that the first step we're going to do is subtract 3 from both sides, because subtracting 3 is the inverse operation of adding 3, since this is originally positive. If I want to get rid of the number, I would use the subtraction property of equality on both sides. That's going to leave me with -2y is equal to 8. Now we have one more step here. Go ahead and pause the video and see if you can figure out what will happen when we do that next step of inverse operations. Okay, our next step is to divide by -2 on both sides. And that is going to give us the value of y, which is y is equal to -4. Watch out for your positive and negative signs here. Make sure you have the correct sign on your answer. So I have y equals -4. So now I'm ready to actually write the answer, which will be a coordinate pair with my x number listed first, 3, comma, -4. Okay, now we're going to go ahead and take a look at question number 1. Question number 1 is actually going to be more difficult than the one we just did because it's going to have extra steps at the beginning. Let's take a look at what I mean by that. Okay, here's question number 1. Question reads 9x minus 2y equals negative 21, and the second equation is 2x plus 3y equals 16. Now in the last system, we check to see that they're both written in standard form, which they are. Now the second step though, when we try to figure out whether the x variables or the y variables have the same or opposite number as a coefficient, you should notice that the x's do not have the same or opposite, and the y's do not have the same or opposite coefficient. Due to that, there's going to be an extra step at the beginning if we're going to solve this. So let's take a look at how we're going to do that now. Okay, so these are the same equations, just rewritten, so it's easier for us to take a look at. Since we do not have the same coefficients, we're going to have to make these equations have the same coefficients. So I need to look and see if I can turn one of the numbers into the number that's paired with it. For example, if I could turn 2 into 9, but I cannot. Or if I could turn one of the y values into the other y value. Now, since that case is not what's happening here, what I'm going to do instead is I am going to multiply both equations by a number to make either the x's or y's have the same number. I've decided to turn the y's into the same number. So how I'm going to do that is I am going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 2. Forgive me, guys. My dog's barking at my neighbors, and I'm trying to get him to calm down. Now, when I do this, I am going to end up having a 6 in front of the y variable in both equations. One will be positive and one will be negative. So I want you guys to go ahead and try to write what these equations will turn into after I've multiplied the top one, everything by 3, and everything on the bottom by 2. Oh, bit of a mistake there. Let me fix that. So go ahead and pause the video and try to work these out on your own, and then I'll come back and we'll take a look at what these equations are supposed to look like after you've rewritten them. Okay, hopefully you guys came up with the same thing as I did, but if you didn't, we're going to walk through how we got there. So first, let's take a look at our top equation. The first thing I would do is multiply 3 times each value inside parentheses, because this is turned into distributive property. So I'll have 3 being multiplied by 9x. That's how we got 27x. After that, I multiplied 3 by negative 2y, and that gave me negative 6y. And then we have to multiply on the right side of the equation as well, because remember, you have to use the properties of equality. What you do to one side, you have to do to the other. So then we also have negative 21 times 3, which gives us negative 63. Now we'll go ahead and take a look at how we came up with the second equation, the one on the bottom. We multiply 2 times 2x, that gave us 4x, and we multiply 2 times 3y, that gives us 6y. And on the right side, we multiply 16 times 2, and that gives us 32. Now, let's go back to why we were doing that. The point of all of this was so we could have the same or opposite coefficient in front of one of the variables. 27 and 4 are not the same, but negative 6y and 6y both have a 6. So I'm going to come over here to the side and decide what operation I need to do to make those become 0, so I can eliminate the y variable. So think about it. What operation would you need to do to make these two numbers become 0? Go ahead and pause the video and see if you can come up with that on your own. Okay, I'm hoping you guys came up with addition, because this would make it the same as 6 minus 6, or what it is, negative 6 being added to 6, which would equal 0, because these two numbers are additive inverses. So that means for us to find our new equation, we are going to add all of the like terms. So we'll start by adding the x terms. 27 plus 4 will give me 31x. Negative 6y plus 6y will give me 0y, and so that will cancel out because it will become 0 times y, which equals 0. So I'm just going to go ahead and move to the right side now. So 31x is equal to negative 63 plus 32, which is negative 31. Now I need to solve for x using inverse operations. So go ahead and pause the video and make sure you know what that first operation will be, and then I'll show you. All right, so we will divide both sides by 31 using the division property of equality. This will give us x is equal to negative 1. So now once again, you have one of the values for your answer. You need to take negative 1 and plug it back into one of the equations to solve for y. Now, what's interesting about this problem is you have a lot of equation options to choose from. You could choose to plug it back into one of the equations you created, or you could plug it back into one of the originals. I'm going to choose to plug it back into the bottom original equation, which was 2x plus 3y equals 16. So give me just a moment and I'll write up that equation for us. So as we were saying, we'll take our value for x, which is negative 1, and we'll substitute that back into one of our original equations, or one of the new equations you created by multiplying. Personally, I think this bottom equation might be easiest to work with. So I'm going to use 2x plus 3y equals 16, but you could have used one of the others if you wanted to. So I want you to go ahead and pause the video and try plugging in negative 1 into one of your equations so I can see if you can do the substitution step correctly. Okay, so if you plug the value in correctly, you should have 2 times negative 1 plus 3y equals 16. Remember, when you're trying to solve an equation, the first thing you should do is check to see if there's any way to simplify the equation or make it easier to work with. We're not just going to go straight to inverse operations on this one. We can go ahead and do 2 times negative 1. That will give us negative 2 plus 3y equals 16. Now we're ready to use inverse operations. The first thing we're going to do here is add 2 to both sides. That is going to leave us with 3y is equal to 18. Now, I would like for you guys to pause the video and see if you can determine what the final answer for y would be after doing the next step. Hopefully you guys came up with division. We will divide both sides by 3. Which will give us our final answer of y is equal to 6. Now we have an x value and a y value, so we're ready to write our answer as a coordinate pair. X was -1, so it will be listed first, and our second value was 6. It'll be listed second. So that would be our final answer, -1, 6. All right, guys, so that's going to be it for this lesson. If you guys have any questions, feel free to put them in the comments of the video, or you can send me an email if you have something you want to ask me directly. And hopefully, by the time we do our next lesson, I can get the webcam back up and working. That way you guys can see me when we talk as well. I hope to hear from a lot of you guys soon. And this will be it for now. See ya.